Okay, everybody, I'm going to go over the study guide. I'm going to break it up into parts, so I'll do each page as a separate video, so you don't have to scan through a whole huge video. Okay, so question number one, we have a building inspector makes a claim that the percentage of new constructions with serious code violations is 7%. So I like to always go ahead and write out my null and alternatives so that way I know what kind of test I'm running, whether it's one tail, two tail, whatever. So the 7% is the null. A second building inspector suspects this claim because he thinks the percentage is lower. So that means our alternative is that P is less than 7%. Alpha is 0.05. Hang on. Okay, so some other information that we have, we found that 13 out of 200 had serious code violations. So this is our information for P hat. P hat, if you remember, is X over N. So that's our 13 and our 200. Now, because this one is dealing with proportions, this is going to be a one prop Z test. So what I'm going to do is in my calculator, whoops, not bars, stats, I'm just going to run the test in my calculator. And hopefully you guys have watched those videos and learned how to run these in the calculator now. That makes things so much easier. So P sub O, that's your H sub O. So 0.07, X was 13, N was 200. My alternative, we wanted it to be less than. So here's the information that we get. We get a test statistic of negative 0.2. So we're only 0.2 standard deviations below the mean, which is not very far. And we get a p-value of 0.39. So that's the piece of information that I'm going to use to make this decision. Because your p-value is very easy. All you have to do is compare it to alpha. And ideally, if your p-value is less than alpha, then you reject. Our p-value is clearly not less than alpha, so we fail to reject. So option A is our answer. We cannot reject. Okay. Moving on to the next little group here. A drug company makes a claim that the mean amount of naproxen sodium in a tablet is 220 milligrams. So that's my null hypothesis. The mean is 220. So I know I'm doing one of my test of means, so I can go ahead and exclude this. A pharmacist suspects this claim and wishes to test it. And I even put a little note on this one. Notice that the pharmacist does not wish to test higher or lower, simply test the claim. So that means for our alternative, we use not equal. And it doesn't tell us any difference, so we're going to use 0.05. So this is the only information that we really have. And you notice that they gave us a data set. So typically what happens, not always, but typically when they give you a data set, it's going to be a t-test because no other information was given. And it's a t-test because sigma is unknown. So since they didn't tell us a population standard deviation, then we have to go with the t-test. So what I'm going to do for this problem is put my data into the calculator. Oh, I already have it in there. So I've got those 5 data values in here. And now what I'm going to do is I'm going to run my t-test. So I go to t-test. I want to make sure that I have data. I want my null hypothesis to match. I want to make sure I'm on list 1. And all I have to do now is change my alternative. All right, so with my alternative set to not equal, I'm going to calculate. So here's some information I have. Let's see. The next question asks, what is the test statistic? So my test statistic was given to me as T. So just making sure that it's negative. So we have A for our test statistic. And then it says for question 4, what is the appropriate decision to be made? So you could find your critical value and make that determination. What I'm going to do though is just simply use the p-value. So remember we talked about in problem number 1, if your p-value is less than alpha, then you reject the null. So our p-value is 0.007, which is less than 0.05. So this tells me we're going to reject the null hypothesis.